Good afternoon, good morning, wherever you're watching this from. The presentation this afternoon is going to be in two parts. I'm going to do the introductions and go through some of the data curation, and then Frank's going to take over and do the clever stuff in the second part. Now, I've just going over that again. I've been in data analytics for about 30 years now, and in that time, I've seen a lot of different technologies coming online. I mean, I can go back to punch cards and 5.25-inch floppy disks, and we've seen that evolve through to data lakes and even the new data gravity wells. But with all this new technology, we still find we're getting the same issues with the data. So we're still looking at where is it, or how do we get to it? What do we do with it, and where we put it when we do get the data? And what do we do with it once we've got it all together? And these questions, we keep asking them over and over and over again. And so if I pull up the next slide, so this you'll all be familiar with. This is sort of the modern data stack, as we call it. And basically, in a lot of cases now, it's failed. Because we have the source files or the data that we have to ingest into some sort of technology. We have to gain access to that information. So we have to put the security stuff in there, the settings in there. We have to do some transformation. We have to do some scripting. At this point, then we may have to do some documentation about what we've done before. That's okay, but then we have to go back and we change something. We have to go through that process again and redocument. Then moving forward, we store script, and this process goes over and over and over and over. So it becomes very, very time consuming, very, very fragmented, and in some cases it can really get really complex. It's also time consuming to get from source file through to visualization tools or data that actually business users can use, or to get it to a point where we can give it across to the data scientists. Okay, now this normally these type of things. I mean, we're looking at these lots of expensive tools here. It can be very expensive. They can be in a lot of large teams of developers and things like that. And as I said before, there are many different tools. Now, this is just an idea of the state of the data engineering map as of last year. Now, this is just some of the tools that are out there that we all use and we all have used. Now, some of these are excuse me, some of these are the top of the end stuff. Some of these are little pieces that we pull in and out of there. You may have some of these because it's best of breed. There may be some stuff in here that you use or you have used in the past because your CEO's nephew's brother-in-law has been a startup software company, and you pull that in and just use it for a couple of times. The guy uses it because it converts something in a different way. That guy leaves. You don't know what's happening. You don't know how to do it. And all these different tools can create and can grow and can turn into not just little gremlins and little tasks that you have to perform all the time, but they can get to and turn into a Frankenstack. So it becomes uncontrollable. So it's a way of, you lose track and you lose the process within what you're going to try and do. And what we're going to try and look at today is how we can sort of tame that Frankenstack. So how we can pull all the information back, or all the implementation side back, and try and get it under one controlled format. Okay, and we're going to do that by looking at how we do it within a company. So we're going to look at, you probably recognize the Silicon Valley references here. So what we're going to look at how a larger company, so if we take the top, Gavin Belson is the Chief Executive of Hooley, and Laura Breen, she works for him, and what they've done, they've acquired Pied Piper. Okay, but what they want to do is they want to merge all the data. So they want to bring the data in and they want to give it over to the data engineers. They wanted the data engineers to be able to work with it, to give it up to relationship management, to give it up to the Chief Executive Officer really quickly. But what we also want to do in that process, we want to leave the data available in a lake somewhere so we can have the data scientists able to access that data. Okay, So we're going to try and merge everything together within and try and tie everything together with the one tool instead of using 30 or 40 different tools. Okay, so what we're going to look at today is we're going to get reporting stuff done for business users who are going to be looking for reports and dashboards that are reliable with created data, and also they want to do they're going to ask for ad hoc analysis. Okay, then we're going to get to the data engineering piece, where we're going to connect, we're going to integrate, we're going to clean prep the data, we transform all that and get it ready for the business units and the reports and the dashboards. And also, we're not going to forget the data scientists. We're going to create the data and give them access to the raw data and curated data so they can merge that and they can look at discovering patterns and they can do the ad hoc analysis that they need to do. Okay. So remember all the tools that we had before. Wouldn't it be great if we could get something that sort of organized and orchestrated all this for us? And we think, or we're going to show you today with the aid of Timextender, how we can do that. Okay, so what Timextender basically does, it's an abstraction piece of software. It's an abstraction-less piece of software that works basically on metadata. Okay, so it sits above your existing data technology. Okay, and what it does from there, it gives you the ability to connect the data source. It gives us the ability to ingest the data into a data lake, and then we can do the curation in a modern data warehouse. Okay, today I'm going to be using Azure Data Lake. I'm going to be using Azure SQL Server. And on the end, what we're going to do, we're going to push it out to what we call a semantic model, and I'm going to be using Power BI just to show you. And this is all in one UI. So we're going to be looking at this in one one user interface. We're not going to be jumping in and out of stuff. I'm going to be jumping in and out of it just to show you different things, but it can all be done on a simple low code drag and drop user interface. Okay, so what it's going to help us do, it's going to help the chief executive and Laurie at this time. We're also going to be able to help out data engineers from one piece of software, and not forgetting we've got the data scientists who have access to everything that we're going to do. Okay, so what we're going to do in a little demo shuts case we're going to go through today. This is the first part. Then at the bottom, when we get to the data science team, I'm going to transfer it over to Frank. I'm just going to take the role of sort of data engineering to start with, then I'm going to hand it over to the data science team. So what we're going to do, we're going to look at it from the Hooley Pied Piper set. So Hooley's just acquired Pied Piper. So we've acquired a new company. I need to onboard all that new data into the data lake. I'm going to consolidate it into a new ERP system. Okay, we're going to add to an existing dashboard that we've got created. So we're going to add it to a Power BI system. Okay, we're going to add some new measures. We're going to add a new gross line total. We're going to load some exchange rates from an API and convert some sales figures into euros. Okay, and while I'm doing that, we're going to do all the documentation that we've done for everything that we've done in the background. Okay, and we're going to do that in about 15 minutes, something like that. Once we've done that, we're going to give Frank a call, and then Frank can take over and do some other sort of magic, some witchcraft. So what we're going to do to start with is jump into Timextender. But firstly, what I want to do is looking for it. I'm going to jump into, so this is my Azure. So this is my container where we're going to put the information in my data lake. Okay, what I also have in here, I have my data factory, so I can create pipelines. Timextender can create me the pipelines that I'm going to use to get the information up into my data lake. And also what we've got here, this is the portal side of Timextender. And as I mentioned earlier on, we can have multiple data sources in this. I have multiple data sources already created. If I want to add a new data source, just go in here and pull down to a data source that I needed. It's Microsoft Dynamics, go to Microsoft Dynamics, fill in the information, and then the data source becomes available to me with the Timextender. So without further ado, let's move through. As I stated before, moving from left to right, so we've got our what we call our ODX, or Operating Data Exchange, which is basically our data lake. This is my data lake over here, and it's connected at the moment to my ADL, as you've just seen. I'm going to add a data source to this. So if I go in here and just add a quick data source, I'll go away and I'm going to call this AW 2019 and go to next. I'm going to pick one of my available data sources. So I'm just going to pick Glasgow. It will let me. There we go. And go to next. The software is asking me now, do you want to pick all the tables in the range? Well, sometimes I do, sometimes I don't, but I'm going to cherry pick a few out. So I'm going next. What happens now is the software will go up, it'll check the data, and then what it'll do, it'll bring me a table listing back so I can see the tables that are in my original data source. So I'm looking in here, and what I want to do, I only want to pull 3 or 4 tables across just to start with. I could pull them all, but I don't really want to do that today. So we're going to do product model, product, we'll do sales order header and sales order detail. Okay, any point while I'm in here, what I can do a quick preview of that table. So without having to give access to the back-end system, I can go in here and I can run a SQL query against that data just to see that the format's correct and everything's right. And you can do this in code, but it's a lot quicker doing it like we're doing it at the moment. What I can also do at this point, I can go into, if they're larger files, and I know there's a lot of columns in there that I don't need, I'm going to start selecting columns, like getting rid of columns that I don't need, remove this column, add this column here. Do that again. We're going to leave everything as it is. Okay, so I've got my 4 tables that I need. I'm going to go to next, and I'm going to create a transfer task, and I'm going to call it get file or get data. Okay, and finish. The software's already gone away. Still not synchronized, so it's synchronized and it says, okay, we've got all those tables that you need that you pulled across. They're in the right formats and everything. So what I'll do now, I'll just execute a transfer, just pull a transfer in. What I can also do at this point, while the data is coming across, I may not want to pull all the data in all the time, so I may just want to do a delta load on this. So what I can do with software as well is if I go into here and I can add an incremental load. I can set up an incremental load at any time that I want. I just need to go into add. Excuse me, and what I'm going to do a column. I'm going to ignore case and I'm going to look for modified date. Spelled it wrong. And a quick refresh. Okay, and what it's done in the table, obviously the 4 tables I've got there, what it's going to do now, it's going to create me a delta load, an incremental load based on the modified date in those columns. So Timextender's done that for me. Okay, so click on OK there. Okay, the data's gone in completely as I wanted it to. What I've also got here, if I go back up to my data lake and a quick refresh, I can now see the information is in my data lake and it's available in Parquet. So now it's available if I wanted to. I could give data science a call and they could carry on from here. So I've got a Parquet file they can go straight into. Okay, so let's go back to Timextender. Let's do some curation. Let's do a bit of data engineering while we're in here. Okay, so what I'm going to do now, the screen, I only want to concentrate on a few tables to merge and to consolidate stuff again. So what I'm going to do, I'm going to create a little perspective, which is tied in. It's dynamically linked across to my my endpoint, my data mart. Double click on my thing, and what that does, my perspective, it just basically breaks everything down. It just shrinks everything down to the actual tables that I'm going to be using. So at this point, what I can do, we can go and we can start selecting tables and bringing tables in. So I can look at my data lake. So these are the tables that I've ingested into my data lake. So I can see, right, what I'm going to do with Timextender is I'm going to start merging the tables together. So I'm going to start merging the ERP system together. All I need to do is highlight the product table, drag it across, drag it over product. What do you want to do with it? I want to do smart sync. Timextender goes away. It says, okay, I've synced it up, but there's a couple of tables. There's a couple of columns that I don't know about, and it's highlighted the columns that it doesn't know about. It's basically based on column header and format. So what I can do from here, if I look at the mappings, I've got my 2 mappings, highlight my new mapping, and over here I can see in lowercase the ones that aren't mapped up. So all I need to do is drag across, go down to size. Timextender lets me drop it over the top. I've got a weight one here, drag it down, and Timextender lets me drop it over the top. Based on the same format, it won't let me do anything else. Okay, so that table's done. Let's go back, let's do product model. So we'll do exactly the same. Product model. And through, that's okay. I've got no mapping errors on that one, that's fine. Let's do the same with sales order header, sales order detail. So I bring my sales order header across. That's fine. And then sales order detail. That's cool. That's fine. So part of our brief, we need to bring some exchange rates in. So what I need to do, I need to bring a brand new table in that I'm not mapping together with the information that I've already got. So if I go into my exchange rates table, which I've already dragged in, and this is an API file, all I need to do is drag the entire table across and drop it into my data warehouse. What I've done at the minute, I've not broken anything yet. I've not changed anything in the data warehouse. This is all in metadata. So I've got nobody ringing me up at the moment saying you've broken stuff, because I've not executed it. I've not deployed anything yet. Excuse me. So what we can do from here, I can look at my table, and because this is an XML table, it comes across and it's got no primary key. So what I'm going to do firstly, just add, include that into my primary key. Then what I can do, I'm going to make a link. So I'm going to make a relationship between my exchange rate table and my sales order detail. But the table, the columns I want to join together are different formats. So what I need to do is just go in here, edit my field. This needs to be a chart 10. So all I need to do within Timextender is change the format. Then Timextender will let me create a join. Ask me if I want to create a relationship. Yes, I do. As soon as I've created that relationship, I can now drag in my new base rate calculation. So this is now my, do you want to use the default? It's asking me, do you want to use the default relationship you just created? Yes, I do. So I've pulled that in. I've got my rate calculation in here. So I'm going to just quickly edit that condition. And we're going to call that exchange rate. Euro. Okay, great. So that's my new fields. You see all the tables are in red. That's because we've changed them. They're what we call dirty tables at the moment because we've not actually run any executions against them. So what I'm going to do now, within my sales order, I've got to create a new field. I've got to create a new measure, my line total, my gross line total. So I can go in, I can do a quick add field. Within this, I'm going to call this gross line total. It's going to be a numeric, and I'm going to click on OK. So I've got my new field, gross line total down here. What I need to do now is add a calculation to it. Transformation, I'm going to go custom transformation. As soon as I hit custom transformation, we jump into transformation SQL. Okay, so in here, what I'm going to do, I'm going to create my new quick calculation. So I'm going to do my unit price. We're going to times that out, excuse me, by my order quantity. And again, because I want this to be the gross line total in euros, I'm going to then times that out by my exchange rate. Okay. What software has also done at this moment in time, it's given us something we call parameters. Now, parameter in the software is basically, it's a link between the field and the metadata. So Timextender always remembers what the field was called initially. So it's a link. Let me show you that a little bit better. Picture the scene, a couple of months down the line, a couple of weeks down the line, somebody comes across and says, okay, unit price, we need to change the name. Obviously, we can do impact analysis on this, and I'll show you that in a moment. But they come across and they say, okay, we need to change that field name price. So we go in here, we do edit field, and we call that US dollars. Okay. Any piece of software I know or I've used in the past, that would break all my calculations down the line. But because we're using parameters and we're working in metadata, Timextender will change it downstream from here. It will change the calculation for you, so you won't have to go through and rechange the calculation at any point. Okay, so we're ready to go. What I need to do now is just do a quick deploy and execute. So we start from there. And this is where we jump into version control. So I can just give it a version. I can just say, just quickly, because we are in a demo, AW 2019, and we can save that. So the software is now gone away and it's writing all the code that we've just done the drag and drop for. Once it's done the code, what it's going to start doing is shifting or moving the data from the lake, doing the calculations to the data warehouse. It's going to prepare it and get it ready for me to put it into my data mart. So anything in orange is a data transformation or a data movement. Anything in red is a table creation, and then blue we've got some code cleansing. Okay, that's finished. So I close that field there, that section there. I can open up my endpoint at the moment. So what I want to now do, I want to add my new gross line total. Okay, so I've got my new field here, it's ready to come across. All I need to do is drag it and drop it in there, that field. My new gross line total is basically, I'll just give it is euros. Give it a description. At this point, we can format the data. So it's currency, and it's going to be in euros. And we click on OK. And at that point, what I can do, I deploy and execute again. We're doing this separately at the moment, but what I will do in a moment is tie it into a job. So this is AW 2019. So we can run it on a daily basis. That's gone through. Okay, that's the model. That's created the new model. That's added the new data. If I jump across into my Power BI model and I just do a quick refresh, we can now see the software is updated. I've not done any modeling in the Power BI. All the modeling has been done in Timextender. I've got my new field. I can pull in. I can use that directly. I can use that straight away. My new gross line total in euros. Okay, let's jump back into Timextender. So we've nearly finished. What I said before, we're going to look at all the documentation as well. So we have, at any point, I could tie what I've just done into a job. So I could add a job. I could create a daily job. So this gets updated. So we get the incremental loading done. We get this updated, and I can set it whatever I want. So I can pick whatever part of the software or whatever parameters I've been using, put them into a job, move it forwards, tie those into a schedule. What I also can do is the gross line total field. Any of the fields that we're looking at the moment, what I can do data lineage on them. So we click on OK, data lineage. We're going to go through. It's going to generate. It's going to do that, which is fine. Yeah, did it. Let's try again. Never do a live demo. There we go. Data lineage. So what it tells me about, it tells me everywhere I'm using that field. So I've got the gross line total where it ends up in my semantic model, the transformation I've done on it. So it tells me the transformation in its raw form. Okay, the data sources it came from and the actual right back to the data source we've got in there. We can then do documentation on this. So I can right click, I can hit my documentation, click OK, and software goes away and it will pull me back documentation for this level. So we've got full documentation at the moment, which is all hyperlinked. So I can look at my new sales order detail. It gives me all the field names, all the formats that are in that table. It gives me the indexes. I've got my new line, gross line total in there. What it also does, it gives me all the links in and out of the software, in and out of that column, that table. So I can see what's linking in and what's coming out of that column. Okay. Again, we can do that at that level. We can do it at ODX level. So I can do, which is a data source level. So I could run documentation at my data source level. So hit documentation in here, and then I can go right back to my source data. This is really good. If we're pulling all the tables across, we can just pull all the tables in. We can do a quick synchronization on it, and we can go back and we can look at the formats within the source data set. There we go. So what I'm now looking at is I'm looking at where I pulled the information from. So I can see my Derby tables. I can see my new AW19 table. So I could go in there and I can look at my source tables, see what formats my source tables are in, so I know what sources we started off at. Okay, so that's the curation bit done. That's a little bit of data engineering done. How are we doing for time? That's not too bad at all. So let's just jump back. Okay, so what we've done in 10, 15 minutes, we've acquired the new company, we've done all this. We've created the new gross line total measures. We've done loaded the API and converted the figures to euros. We've created all the documentation. So now what we need to do, call the data science team. And at that point, I can hand over the data to my mate Frank, and he can do some wizardry. Just let me change the presenter. You got it, mate? Yeah.
Yes. Thanks, Chris.
Perfect. No problem.
That was That was very cool. All right. So now let's see what we can do with the data that we got, because like Chris, when I used to do the projects, we also spent like the majority of the time, instead of focusing on the actual use case that we wanted to build out, we spent all the time to get the data and to make it behave and all of that. So we spent a lot of time before we could actually make something of it. But now we got that part sorted in a couple of minutes. So now we can look at using what we built. So in this case, I chose Databricks to use with the data that we have. And this is a Databricks workspace. It is in the same tenant as Chris has been using, but it doesn't have to be. So you could even use this cross-tenant or even cross-cloud vendors if you wanted to. So the first bit I have done, because I need to get access to both the Azure SQL database where we store the curated data, but I also need to access the data lake. I need some credentials. And of course, since now we're here working more on a code base, on a code level, we need to store secrets somewhere. But of course, you never should store secrets directly in a script, obviously. So this is why I used an Azure Key Vault and linked it up to my Databricks workspace to save some credentials in there. I linked all the documentation parts here as well. So if you want to share that notebook later, then of course you can have a look at it. And I just jump over to my Key Vault. You can see I have several of them. It's basically like a key pass, but just in your Azure environment. And if you go to the secrets here, you can see I have, you know, all of the things that I need: application ID, app secret, database host name, SQL user, password, etc. And also the information where my data lake is. So the storage account and the storage container is in here as well. So with the credentials out of the way, we can take a look at how do we connect to the data warehouse. In this case, it's an Azure SQL database, and it is where the curated data is living, so the master data, for example. And again, I need to get some parameters set up. And the way Databricks or Spark in general works is you have these notebooks, and they contain a number of cells, and each cell contains code, and you can execute the code cell by cell. You're probably all very familiar with this already. So, and this first cell here, the first cell that's containing some code, these are the parameters that I need to connect to a SQL server in this case, because it's a SQL server in the cloud, so Azure SQL, this is basically what it is. And we're using this code, db secrets get, to get some secrets from the Key Vault, and these are exactly the parameters that are over there in our Key Vault: database host, database name, SQL user, SQL password. And then I build out a connection string down here that puts it all together, right? So let's execute that part. And that went pretty quickly because we didn't do anything. We just defined some variables. And I'm connected to a cluster in this case, a Spark cluster. A single node is sufficient for what we are doing here. But of course, then you can scale it out to whatever workload sizing that you need. And the cluster is again running in the same Azure tenant, and it will do the actual compute in this case that we are doing. So now I have the parameters in place, and now we can read the customer dimension. And for that, we are using Spark, well, PySpark code, and basically it always starts like spark.read. In this case, I want to read from a JDBC connection using the database connection string that we defined above. And then we go for DB table, and that's the customer master data that I want to read. You could also put in a SQL query in here, but you can also just read the entire table using username and password. And then .load will actually execute this, and then we display the result. So let's see how that goes. And that's perfect. So now I'm connected to the database where Chris has put like the curated data. And we can see that I have surrogate keys, I got my business keys, I got all the columns, you know, numeric columns, string columns, etc. All of this, the GUIDs, all of the things. And also Timextender was so nice to put in behind here some housekeeping columns like the batch number with which execution it got in here, the source code and the timestamp. So this is not super exciting, but it's especially when you put something like this into operation later on, it's super important for observability and tracing down errors and stuff like that. So, and we just get that out of the box here. So that's super cool. So now I'm connected to the master data, to the curated data, and we got the customer table loaded basically into our variable here, customer. So this is a data frame, what we call a data frame. Let's read another dimension, in this case, the product dimension. And let's see how that looks. It's the same code basically. We just changed here the DB table option to MDW product, which is my product table in the MDW schema. And again, I get all the data back here. So that's really cool. Now I have the master data in place, both for the customer dimension and for the product dimension. So that's all fine. Now we have curated data, but how can we get at raw data? Because oftentimes the master data is fine for building out the dimensions, but I want to run my experiments here and my investigation on the latest data. And that is maybe not yet in the data warehouse, but we need to look at the data lake instead, which becomes updated, which is updated more frequently. So to do that, we add a mount point for the data lake. Again, this is a bit of code that I got from the documentation side. Basically, we add it in like a folder that we can use on the local file system. We link the data lake like it and link it as a folder on a certain mount point, and then we can access it like a local folder. Again, we're getting some secrets here from the key vault. App ID, app secret, tenant ID, so usual Azure stuff. And then we do some config stuff to connect specifically to an ADLS Gen 2. We need to specify that we want to authorize with OAuth, etc., etc. So we do it like this. And I mean, these are the things, you know, that take up a lot of time to figure out, but once you have them in place, I mean, this is according to all the best practices, security-wise, and also like how you do it in a more enterprise scenario beyond, you know, just a quick experiment. So once we have the configs in place, we can actually mount the mount point. And then again, we build like this connection string here. Let's just execute this. And then I have created some code here to really mount the data lake. In this case, it will tell me the mount point already exists, but we now also know that we can access the raw data from the data lake using the path MNT ODX ADLS. So this is where we will find now the raw data. And now we can also look at it. So MNT ODX ADLS, and LS is meaning list. So list the files that are in this folder, MNT ODX ADLS AW 2019, right? So this is the database that we just created, or the data source. And then we want to look at the sales order header table. We can just investigate what's going on in that folder when it was loaded the last time. And then we can see there's different loads in here. So there's an entire history built up when this was executed. And the latest one is, the latest full load is from June 26. So that's very good. So now we need to figure out of all these versions of the data, how can we get to the last one? And for that, we can use the Databricks utils to list the code, but do it in a more Python fashion that's more accessible. More people know how to use that. And again, we put in the folder name in here, list all the files. And then the latest version is with the highest timestamp, of course. So we go for the max of the path name. And we exclude the work folder. And then we add to that, we append to that data and that will give us the latest version. And if we execute that, then we will see that we go to MNT, ODX, ADLS, AW 2019, sales order header, and then we identified the latest full load folder, and we appended the data folder at the end. So now we have figured that out, but this is like running one time now. But in order to make it more generic, we can encapsulate that in a function again. Let's call that get latest ODX version, and then we put in the table folder base name, and then it will basically execute the same thing, but we can reuse that bit of code. Of course, that's again like best practice, make it reusable. So with that in place, all we need to do is get our sales order header table. We go again, spark.read. In this case, we don't read from a SQL connection, but we read Parquet files as we've seen in the lake. And we apply the get latest ODX version function. And this is the base name of our table here. And then we want to look at the results. So let me execute that. That also goes pretty quickly, but now the Spark cluster has done the heavy lifting instead of the SQL database. The cluster has read the Parquet files, all the increments that are in there, has combined them together into one data frame, and has returned them in here. And again, I can see that the housekeeping columns are missing. They're not in here. This is the raw data now, but it is all the entire data set, right? So I have sales order ID, version number, order date, etc., etc. That's looking pretty good. Now let's also get the sales order details table. Again, now the code is very simple, right? And now it's repeatable. Sales order detail equals Spark read Parquet, get the latest version from the base folder and display the result. So now we also have the detail level available here. Fantastic. So now what we want to do, we want to bring it together. Now I have the raw data and I have the curated data, the master data from the warehouse and the raw data from the lake, the latest transactions from our operational system. So that's fantastic. But now we need to join them together to perform some actual analysis. And in order to do this, again, we use some Spark code here. And in this case, we start with our fact table, the sales order detail table, and we join onto it the sales order header on the sales order ID column. Both of those have them. Then we join on the customer dimension based on the customer ID. And lastly, we join on the product dimension based on the product ID. So basically, we denormalize. We have all the data frames. We join them together on the common columns, and then we denormalize the data frames and make it into a big data frame. Of course, we don't need all of the columns from all of these data sets. So we select a certain subset of columns. So we go with order quantity, unit price, territory name, which we got, I think, from the customer table. Same for the country region code, category name, subcategory name. And, category name and subcategory name are from the product dimension, of course. And then we have the sales order ID and the order date from the fact tables. But we also can add some additional calculations in here, which are maybe not yet, or attributes, which are not yet persisted in the data warehouse. So we add a region territory, so a combined attribute would go in here, function concat with a white space, combining the column country region code and territory name. And we also add a category subcategory column, combining those two together. And we also can do numeric calculations in here, adding another column, gross line total, which multiplies order quantity times unit price. And then we can also investigate what's going on there. So now the cluster goes out, really retrieves the curated data, retrieves the raw data, and combines it all together across the data sources and across also the two distinct formats between Parquet and SQL. And now we get it all back in one big data frame. And we can see all the attributes that we've selected, order quantity, unit price, etc., etc. but also with the newly added columns back here, region, territory, category, subcategory, and also the gross line total is now calculated in here. I can also get a data profile to get an idea of what the data, so the combined data set looks like. So for the numeric features, it will give me like this histogram, and for the unit price, how's the distribution, what's the min, what's the max, standard deviation, zeros, so typical data metrics. And also for the categorical features, again, histograms, what are the most common values, how's the distribution, etc., etc. So that's already pretty insightful, but we can also go a step further and also again to do like pivot tables in here. For example, using the new regions and using the categories, category, subcategory, and see what sells best in which region, etc. We can even do basic visualization already in here with the two data sets combined, raw and curated. So the unit price is highest, correlates with the gross line total in such and such way across the regions, right? So that's already pretty insightful. It is code heavy now, of course, that's the nature of these tools, but I think it's important to understand now this is pretty easy to operationalize and build on top, like in a continuous process that you can execute once an hour, every night, etc., etc. We can even take it a step further. If I want to make this reusable, I can also write out my analysis. I do the combined data set is called my analysis, write, save as table, and I will just save it out. That will persist it onto the data lake, and then I can even feed it back, let's say, into Timextender and make it again usable in the data warehouse. But I also can perform advanced analysis, whatever that is, wherever advanced starts. But I just threw in some code that I glued together. So we want to have a chart that displays the U by different options here. So we can choose that in a second. And then we do some calculation. So we do on the x-axis gross line total, on the y-axis the order count. And then again, we group by the different options that we have. And then we want to see the sum of the gross line total, the sum of the order quantity, average of the unit price, and the count of the orders. And if we execute that, cluster will again go ahead and perform the calculation based on the combined data set. And now we get on the x-axis the gross line total, and we get the order count. In this case, it's across categories. And we can see, of course, that the bikes are have the highest gross line total per order count, so meaning the orders on average have the highest value. But we can also look at it by country region code, for example. And we can now see that the US is typically ordering the more expensive stuff. And we can go also one step further and look at region and territory, so one level down. And here we can see how this distributes, and we can see there's still a cluster of the most expensive orders, and they all come from US Southwest. So whatever kind of analysis, of course, you build at the end, that is the use case. That is why you call up the data science team. That is, of course, then your business insights and the things that you know. But I think it's pretty important to get good data in and to get it in fast and to be able to really make something of it and not spend too much time on ingesting the stuff. Chris, what do you think?
That's fantastic. I just think it goes to show the speed that we can get the mundane tasks, the repetitive tasks done, so it doesn't clog up your day and it doesn't clog up the business user's day. And I think that's what we're all here for, to get the data to the right people at the right time in a time efficient manner. And I think this is how we do it.